Hi everyone. So our today's lead code question is 3651, that is minimum cost path with teleportations. So this is an hard question. So please be patient. I'll be explaining you each and everything. So be patient and please watch the video full. So in this in this question we are given a matrix m cross n of 2D integer array and an integer k. So what we have to do is we have to start from the top left cell 0 comma 0, and our goal is to reach to the top right cell m minus 1 comma n minus 1. So there are two types of moves allowed in this question. One is normal move, that is from any cell I comma j we can either move to the next cell, that is I comma j plus 1, or to the right, or to the down cell, that is I plus 1 comma j. Means we can either move to the right cell or to the down cell, and the cost of that movement is the value of the destination cell. And the other movement that we are allowed is teleportation. So from any cell I comma j we can move to any other cell x comma y such that the value at the destination cell, that is x comma y, should be less than or equal to the value of the source cell, and the cost of this moment is 0. And we are given an integer k which denotes the maximum number of teleportations that we can do. So let's see this example. So here we are given a grid, and we have and k is equal to 2, and we have to go from the cell 0 comma 0 to the cell m minus 1 comma n minus 1. So our goal is to reach from this cell to this cell, and the movement allowed is either we can go to the right cell or to the down cell, or we can teleport to any other cell at, whose value is less than or equal to the current cell. So right now we are at 1, so we can either go to 3 or 2. So this way, like, we have to find the answer. So we'll be seeing the approach ahead. So suppose we are at 5 right now. So what are the possibilities where we can teleport? So from 5 we can teleport to 3, we can teleport to 4, we can teleport to 5, we can teleport to 3, we can teleport to this 3, we can teleport to 4, we can teleport to this 2, we can teleport to this 1. Means all the cells whose values are lesser than this cell, we can teleport to all those cells, right? So this is like the teleportation thing. Now next, we if we'll see the constraints, the array size can be from 2 to 80, where m is the grid length and n is the columns, like the number of columns, and uh, an element can be up to 10 to the power 4, and the number of teleports allowed is up to 10. So what we will do is, if we'll discuss our approach, what I'm thinking is to use reverse dp plus solve this question in layers for teleportation. So what this solving in layers means, so first of all I'll be solving for t is equal to 0, means there is no teleportation. Then using this data I'll be solving for one teleportation. Then using data of teleportation 1 I'll be solving for t is equal to 2, and so on. So next is like what reverse dp is means. So here we are asked to move from 0 comma 0 to m minus 1 comma n minus 1. So what I'll assume is, I'll assume that I have reached to m minus 1 comma n minus 1, and then from here I'll be going to 0 comma 0. So I'll be solving this question in reverse direction. So assume that right now there is no teleportation, so then how we will be doing this question? So if we have to reach from 5 to 5, means the distance is 0. Then if we'll come to this cell, that is 3, so we can either go to right, and there is no down, right? So what will be the value? So for going to right, the value is the value of the destination cell, that is 5, right? So for this cell 4, we can we are allowed like two rules, either go to right or down. So if we'll go to right, the value is 3. So from 4, this cell to this cell, value is 3, and the previous cost is 5. So 5 plus 3, 8. Now we come to this cell. So we can either go to right or down. There is no right cell, so we'll be going to down. So the value is 5. Now if we come to this cell, we can either go to right or down. So if we'll go to right, the value is 4. 4 plus already stored value, that is 5. 4 plus 5 is 9. If we'll go to down, 3 plus 5, 8. So we'll be taking the down path, minimum one, 8. Here either we can take, see, 8, 8 plus 5, 13. 8 plus 4, 12. So we'll be taking 12 one. Then this way, like we can do this question if teleportation is not there, right? So now the next thing is that how we will be handling teleportation. So for teleportation, suppose we are at some point I comma j, and we can teleport to x comma y, and the condition is that the value at x comma y should be less than equal to value at I comma j. This is given in the question, and suppose we assume that value at I comma j is equal to v. So now what we have to do is we have to check all the values less than equal to v, right? Because those are the only allowed cell, and we'll be taking that cell whose distance to the final cell is minimum, right? What this statement is saying, suppose our current value at I comma j is v, then we'll be choosing one cell whose value is less than equal to v, and whose minimum distance to go to the final cell is like the minimum one. So we'll be taking that. So what we can do is we can use a vector to store minimum distance to final cell from every value. What it means is, suppose I make an array, index 0 denotes that uh, any cell having value 0, and if you have to go to the final cell, what is the minimum distance? So suppose this is 3, 5, wait, 3, 5, 2, comma 6. So suppose right now we have this array, and our suppose our current value equal to 3. So our current value is 3. Then what are the values that we can go? So we can go from value, current value is 3, so we can go to those cells whose value is less than 3, means 1, 0, 1, 2. So if you'll see here, these are the cells that we are allowed to go. So all those cells whose values are whose so these are the cells where we can go. So it is showing, what this showing, that any cell having value 0 and their minimum distance to the final cell. Let me tell you, see here, this is having value 3, this is having value 3, this is having value 3. So this have some minimum distance to the final cell, this have some minimum distance to the final cell, this have some minimum distance to the final cell. So what value of 3 value of 3 will denote the overall minimum value. Like suppose this is taking 5, this will take suppose 4, this will take suppose 2. So value of 3 will be storing the minimum of these all values. So it will be storing 2, because, and now suppose we are at 4, so we can teleport to 3, but which 3? Many 3 are there, so we'll be choosing the 3 that this one, because it is taking minimum distance as 2. I am giving you an example. So we will be using a vector that will store all the minimum distances for each value. What I am repeating again, will be using a vector that will store minimum distance to the final cell for every possible value. Okay, and then next thing is like, suppose our here value is 3, so we have to check all the cells whose value are less than equal to 3. So here the, if you have noticed our constraints, an element can be up to 10 to the power 4. So if we have to check all the cells, in the worst case our time complexity can be up to 10 to the power 4. So that won't be good, like for checking for every cell. So here total cells are 80 into 80, and then checking for every cell 80 into 80 into 10 to the power 4. So that will be like make a solution TLE. So what we can do is we can use a prefix minimum, that is we can compute minimum value up to any v cell. So if we'll use, suppose this array 3 5 2 6, so up to index 0 what is the minimum? 3. Then up to index 1 what is the minimum out of 3 or 5? 3. So we'll be storing 3. Then we will be checking this. So what is the minimum out of 3 5 2? So it will be 2. Then we'll be checking this 3 5 2 6. What is the minimum? 2. So this way we'll be storing overall minimum, that is the minimum up to that value v, from the value 1 to v, what is the minimum that will be stored, because at the end we will be using that only. So if we'll store that in the prefix minimum, then if we have to find minimum value less than equal to v, that then that we can do in big O one time. So what we are do is, like earlier our time complexity was 10 to the power 4 in the worst case, but now it has become big O one time using the minimum prefix. Okay, and now what are the possibilities? So what are the three possibilities of moving to a cell? Suppose we are at I comma 0, I comma j, then either we can move to the right cell, either we can move to the right cell, either we can move to the left cell, or suppose here value is v, or either we can teleport to all those cells whose values are less than equal to v. So for this we will be using the min prefix and check like which one is having the minimum value. So and then we'll be taking minimum of all these three, like what is the cost to go to next cell, what is the cost to go to next down cell, and what is the cost to teleport, right? So whichever is giving us the minimum value we'll be taking that, right? So let's move to the code part. So in this code, like first of all we take the number of our number of rows, number of columns, and then we have defined a long uh, as infinite, and then max value can be up to 10 to the power 4. And then we have used two dps, dp previous and dp current. So why we are using this? So as I have told you earlier, that we will be using teleportation 0 to calculate teleportation 1, teleportation 1 to calculate teleportation 2. So we'll be using these dps for those things. Then we will be calculating for teleportation 0, just like normal reverse dp which I have shown you earlier also. So for any I comma 0, I comma j, sorry, any I comma j, we are checking the right column and the left column, and then taking minimum of both these two. Initially our best is infinite, so whichever is giving us minimum we'll be storing that value. I hope you remember I have explained you here. See, at this point we'll be taking right or left, so that is the thing. And then what we do is, for every t is equal to teleport is equal to 1 to k, so what we do is first of all we store the best value. So what is best value? So I have told you about a vector in which we store the minimum distance from any cell to the final cell whose value is v. Suppose there are 5 cells whose value is v. So in this best value of v will store that minimum distance of all those cells having value v. So we'll be calculating best value v. So what we do is we'll go to every cell of the grid and taking c best value v, and then best value of v is equal to minimum best, means already stored or the current. So we'll be storing the minimum. Suppose there are two cells having value 3, it is taking distance 5 to go to the final cell, it is taking distance 4 to the go to the final cell. So what we do is best value of 3 will store 4, that is if value is 3 then we can go in only cost as 4 to the final cell. So we stored this, but then we have seen that we have to check all the values less than equal to v. So for that we have to store prefix minimum, else the time complexity will be too big. So what we do is prefix min of 0 is equal to best initially the first prefix min is equal to 0, then what we do is prefix min, like prefix min of v minus 1 stores the lowest operations, lowest cost up to the value v minus 1, and then the best value at v stores the minimum distance that the cell having value v takes. So minimum of these two will be stored at prefix min 1, and then what we do is so we like compute dp current. So in dp current, initially we have initialized all the cells of dp current to infinite, right? Then let's see. So dp current of m minus n minus 1, it will be 0 only because we are traversing in reverse order, so it will be 0. Then what we do is we'll check the right part, what we call right one, we'll check the left one, and then we'll teleport. So value at grid I comma j is grid I comma j, and prefix min of this will give us the minimum distance that by which we can go to the final path, and dp current of ij is equal to minimum of all these three. So minimum of all these three will be stored here, and then we'll be swapping previous with the current one, and this will be we'll doing up to k teleportations, and at the end we return the answer dp previous of 0 comma 0. If you like this solution, please make sure to subscribe the channel. Thank you.